Greetings, chemistry students. Today's lesson should be a reasonably short one. It's nothing that I think is too terribly complicated. We're going to wrap up molarity, and then we're going to delve into acids and bases. Just a brief introduction to them. So first of all, we've got dilution. You might be familiar with the fact that dilution essentially means to just add water to something. Well, oftentimes in the chemical laboratory, we order really concentrated solutions of chemicals and then we dilute them to the concentration we want to use before we use them. Just like with laundry detergent. You buy a concentrated laundry detergent and then your washing machine dilutes it with a bunch of water in order to get the concentration you need to wash your clothes. You don't go buy 20 gallons of diluted laundry detergent and just fill up your washing machine with it. That water is heavy, and so if you can take the water out, you reduce your shipping and storage cost. So there's a very simple dilution equation that's found on page 3 of your reference tables. It says M1V1 equals M2V2. In other words, if you know the initial molarity and the initial volume, that's going to equal the final molarity times the final volume. And so I'm going to show you a sample problem with that. It says what volume of 18 molar sulfuric acid, H2SO4, is needed to produce 250 milliliters of 3 molar sulfuric acid. So here's that problem again. Our formula says that M1V1 equals M2V2. So we're wanting to know what volume, we'll call that V1, of 18 molar, we'll call that M1. Sulfuric acid is needed to produce 250 milliliters, we'll call that V2, of 3 molar. We'll call that M2, sulfuric acid. So we can start with 18 molar, add water, and reduce the concentration or molarity down to 3. So we're going to have 18 times V1 equals 3 times 250. So we're going to move the 18 to the bottom there. So V1 is going to equal 3 times 250 divided by 18, which is 41.7 milliliters. In other words, if you start with 41.7 milliliters of the 18 molar sulfuric acid, you can then add water. Apparently you would need to add 208.3 milliliters, because if you add that to 41.7, you'll get 250. And of water, you add that water to it, and it'll become 3 molar sulfuric acid. So let's look at one more problem. If 25 milliliters of 0.62 molar hydrochloric acid is diluted to a new volume of 150 milliliters, what's the new molarity? So we have a volume, V1, and a molarity, M1. We have a new volume, V2. We want to know the new molarity, M2. So we have 0.62 molar times 25 milliliters equals our new molarity times 150 milliliters. So we're solving for M2, so we'll take our 150 and move it to the other side. So our new molarity equals 0.62 times 25 divided by 150, which comes out to be 0.10 molarity. So you'll notice that as we add water, the molarity went down. It started at 0.62, now it's down to 0.1. So that's how the dilution equation works. I'm going to give you a couple of dilution problems to try in today's assignment. But we've got a few more things to look at. The next thing is called colligative properties. Essentially, these are things that as the molarity of a solution goes up, you get more of these things. So the first one is vapor pressure lowering. And essentially what this means is as you dissolve more particles into the liquid, it reduces the rate of evaporation, so you have less of it turning into a vapor above the liquid. You also have boiling point elevation. The boiling point goes up. So for instance, if you add salt to water, the boiling point of the salt water goes higher. If you add more salt, it goes even higher. You also have freezing point depression. The freezing point goes down. If you add salt to water, it's going to freeze at lower and lower and lower temperatures. That's part of why the Atlantic Ocean does not freeze in the middle of the winter. Um, Salt water has a very, very low freezing point. This is also why you use salt, adding it to ice in order to make ice cream, because as you add the salt to the ice, it lowers the freezing point, also known as the melting point, they're the same thing, of the ice, which causes it to melt. And when ice melts, it absorbs heat, and so its temperature actually drops by adding salt to it. So adding salt to ice causes it to melt, and seemingly contradictory, it actually gets colder when it melts because melting absorbs heat. And that's what allows an ice cream churn to actually freeze the ice cream. And the last colligative property is osmotic pressure goes up. If you think back to biology, if you have a little cell and you add more particles into that cell, or if you're working with eggs, I know biology class, you probably do the experiment with eggs. If you add more particles in there, you make a hypertonic solution, and so water tries to come in at a higher pressure. So that's just the list of colligative properties. I wouldn't worry a whole lot about remembering all of this in great detail right now. It's just something for you to be aware of. So the last thing we're going to do is talk about some basics of what acids and bases are. So acids, one of their properties is it has a sour taste. So you ever eat food that's sour tasting, Sour Patch Kids, for example, or Warheads, they are coated in an acid that makes them taste sour. Acids will take blue litmus paper and turn it red. Litmus paper is just it's a test material that changes color in the presence of acids or bases. I wish I could show you the video of this. It's not available online, but there's a little saying to help you remember this. Blue to red acid. Kind of rhymes. So that's second property of acids. Third, acids will react with metals to produce hydrogen gas. And acids conduct electricity in solution. For instance, the battery that's used to start your typical automobile contains what's called a lead acid battery. The acid is in there in large part to conduct electricity within the battery in order to allow the electrons to flow through it. So those are some properties of acids. Then we have bases, which are kind of the opposite of acids. Bases do not taste sour. Bases taste bitter. Bases have a slippery feel. If you get a base on your skin, it feels like you've got soapy water on your skin because, oddly enough, bases will react with the oils on your skin to make soap. So your hands are now coated in a soap that's made of you. It's a sign you should probably wash it off. It's not good for you. Bases turn red litmus paper blue, so they do the opposite of what acids do with that. And they conduct electricity in solution. One other thing you should be aware of about bases is bases will dissolve proteins, and essentially your body is largely made of proteins. Your skin, the lens of your eyes, your muscles, they're all made of proteins. So bases will dissolve those things. Your hair is made of protein. Drano, for example, which is used to unclog drains, is essentially a really concentrated base, and it will dissolve any hair or grease or fat that's clogging up the drain. So those are some properties of bases. We'll go into more detail about acids and bases tomorrow. So I've got just a little activity for you to work on at this time. Good luck.